So let's learn how to write ionic compounds. This is part one. This is the easiest type of ionic compound to write. I call it drop and plop. Remember, just by looking at the periodic table, you can predict what the charge might be. So all of these nonmetals over here are going to have a negative charge because they gain electrons. All of the metals will have a positive charge because they tend to lose electrons. So let's look at one example. Here's sodium, and it has lost one electron, which gives it a positive 1 charge. Here's chlorine, which has gained an electron, and when it does, it becomes an ion that we call a chloride ion. You'll notice that the charges are equal. In other words, they both have a magnitude of 1, and the charges are opposite. Sodium is positive, chloride is negative. When that's the case, when your charges are equal and opposite, you can simply write the elements together, and there is your ionic compound. So this is sodium chloride. Let's take a look at why this works. So let's see how we can make sodium chloride. I'm going to start by selecting a sodium ion and a chloride ion, and you'll notice that the sodium has a positive 1 charge, which means that it lost an electron. The chloride, or the chlorine, has a negative 1 charge, which means that it gained an electron, and we would call that a chloride ion. When I bring those two together, they form a bond, and you'll notice that the positive 1 charge and the negative 1 charge cancel each other out. The way we would write this is NaCl, meaning I have 1 sodium, 1 chloride ion, and it's called table salt. Here's another example. This is iron 2, and it has a charge of positive 2. This is oxygen, which forms an oxide ion with a charge of negative 2. And again, you'll notice that the charges are both equal. They're both 2, and they are opposite, a positive and a negative. When that's the case, you can simply drop the charges and plop the elements together. In this case, it forms iron oxide, and there's the formula. Let's look at why that works. In this example, I'm asked to make iron 2 oxide. Now you'll notice that there's 2 different types of iron down here. And that's just because iron is a transition metal, and because it has its electrons in the d orbitals, they can form either positive 2 or positive 3 ions. And the way we distinguish them is we use Roman numerals to say we're talking about the iron that has a positive 2 charge that lost 2 electrons. So now I'm going to find my oxide ion. And you'll notice that my charges are equal and opposite. I have a positive 2 and a negative 2, and when I bring them together, they form a bond. So this iron is losing 2 electrons, and the oxygen is taking those 2 electrons, which forms an ionic bond. Now when I write the formula, all I need to say is that I have 1 of each. I have 1 iron and 1 oxide. So I simply write it FeO. My drop and plop rule also applies to polyatomic ions. Poly means many, atomic means atoms. So in this example, we'll be using sodium and a hydroxide ion. You'll notice that the hydroxide ion is made up of an oxygen and a hydrogen, and that together they carry a negative 1 charge. But again, the charges are equal, so each are 1, and they're opposite. I have a positive 1 and a negative 1. So I simply just drop the charges and plop the 2 elements together to make sodium hydroxide. Let's look at why that works. Let's look at how to make sodium hydroxide. So here's my old friend sodium that has lost an electron. And then I'm going to look at the hydroxide ion. Hydroxide is a polyatomic ion. Poly means many. Atomic means atoms, so it's simply an ion that is formed of more than 1 atom bonded together. So if I were to bring my sodium to my hydroxide, you can see that I form a bond, and you can see that my positive 1 charge, the 1 electron that was lost by the sodium, could be gained by the hydroxide. Remember, hydroxide ions tend to gain electrons. So the way I would write this formula is NaOH, which means I have 1 sodium, 1 hydroxide. Okay, last example, once again with a polyatomic ion. This time we'll be using aluminum that has a positive 3 charge and a phosphate ion that has a negative 3 charge. Don't be alarmed by how complicated phosphate looks. You should just notice that the charges are both equal, both of them 3, and they're opposite. One is positive, one is negative. So all I need to do to write the formula is just drop the charges and plop the elements together. Let's look at aluminum phosphate. Aluminum has a positive 3 charge, which means aluminum ions tend to lose 3 electrons. The phosphate ion is this. It looks complicated. It's a phosphorus with 4 oxygens, and it carries a negative 3 charge, which means it can accept 3 electrons. Now, it just so happens that if you notice, the charges are equal. They're both 3, and they are opposite. One's positive, one's negative. This one's losing 3 electrons, this one's gaining 3. And if I bring those together, it forms a bond. And when I look at how to write the formula, I would write it as AlPO4. What that means is I have one aluminum ion and I have one phosphate ion.